Here we have some word problems that you can use trig to solve. So we need to remember our trigonometric ratios for sine, cosine, and tangent. SOHCAHTOA will help us with that. And then we just need to know how to use those functions on the calculator. And we can probably figure these out. Let's look at this first one. This is a pretty typical type of trigonometric word problem. It says a ladder leans against a building, forming an angle of 59 degrees. So this must be the ladder then. And the building is here. I guess that's the side of the building. It forms a 90-degree angle with the ground. So you have a right triangle here. So we know we can use trig. And we want to find the length of the ladder. So this is going to be x. And we're given this distance of the ladder from the building as 4 feet. So we've got an angle. We've got a side that we know, a side that we're looking for. So we can use trig to figure this out. They're actually telling us here to use the cosine. We didn't need to know that. We can look right here from the perspective of this 59-degree angle that we have an adjacent side and we have the hypotenuse. So adjacent hypotenuse, that's ka, that's the cosine. The way to set this problem up is the cosine of 59 equals the adjacent, that's 4, over the hypotenuse, and that's the one we're looking for, so we're calling that x. Now we need to do a little bit of algebra before we pull out our calculator here. We've got x on the bottom of a fraction. I'm going to multiply both sides by x to get the x off the bottom there. So those two x's cancel. Now we have x times the cosine of 59 equals 4. Let me just rewrite that here. Whoops. So x times the cosine of 59 equals 4. And to solve for x, we just need to divide by this cosine of 59. All right, so that's the algebra we need to do. These two cosines of 59 cancel. We just get x equals 4 divided by the cosine of 59. We can do that on our calculator. So we're going to take 4, hit the divide key, then type in 59 and hit the cosine key, and then hit the equals to make the division happen. We end up with 7.7, well, let's round to a nearest hundredth, 7.77. And at this point, I usually ask myself, does this seem to make sense in the context of this problem? If this distance is 4 feet, is it reasonable for a ladder to be almost 8 feet? And yeah, that seems to fit. Let's try a couple of others. Here are another couple of problems that are typical with trig word problems, and they have some terminology in them that if you're not familiar with, it makes the problem really hard to solve. This one's about an angle of depression, and this one's about an angle of elevation. And these concepts aren't that hard, but if you've never heard of them, it's going to be tough. So let me show you what the angle of depression means, what the angle of elevation means. In this one, it says an airplane over the Pacific sights an atoll at 11-degree angle of depression. Well, there's a lot there. Let's unpack that a little bit. So we've got an airplane. Always good to draw a picture, and I like drawing airplanes. So there's an airplane. And it's flying over the Pacific Ocean. So there's our Pacific Ocean. That's supposed to be a straight line. And it cites an atoll. What's an atoll? Well, it's a little coral outcropping island that just rises just barely above the surface of the sea. And when it says it sights, an airplane sights it, you imagine some person in the cockpit here looking down and seeing that atoll. So there's their line of sight. Imagine that's also a straight line. Then it says if the plane is 510 meters above the water, so let's drop an altitude here. When we do that, that'll be up a 90-degree angle, and we know this side is 510. Suddenly, we have a right triangle, and we can use trig. The only other piece of data we've got here is this 11-degree angle of depression. Where does that 11-degree angle go? Just looking at the picture, you can probably guess that it's going to go in here, and that's correct. This angle right here, the distance between the sea and the line of sight, so think about it going down from the line of sight to the surface of the sea. That's our depression, our angle of depression. Now it says, how many kilometers is it, that means the plane, how many kilometers is the plane from a point 510 meters directly above the center of the atoll? So imagine going up 510 meters. Well, that would bring you directly to the level of the plane. So they want to know this line right here. Well, luckily for us, that's the same as this line down here. It would just be raising that up. So the length is going to be the same. So this is actually the side of the triangle that we're looking for. Now we've got an angle, we've got a side we know, a side we're looking for. We can use trig. So from the perspective of this 11-degree angle, let's figure out which sides we have. Looks like x is adjacent, and this is the opposite side. So we're going to use a tangent ratio. TOA, tangent, is the opposite over the adjacent. So we'll set it up like this. The tangent of 11 degrees equals the opposite, that's 510, over the adjacent, that's x, what we're looking for. Again, we've got x on the bottom, so let's multiply both sides by x. These x's will cancel. We've got x times the tangent of 11 equals 510. Let's divide both sides by the tangent of 11. And we get x equals 510 divided by the tangent of 11. A little messy, but it's the same algebra as the last problem, so I hope that's okay. Let's try this. We've got 510 divided by 11 tan equals. So I've got 2,620, well, let's round it to 2,624. Does that make sense in the context of this problem? These are meters. The plane is 510 meters in the air. Could this side be 2,600 some meters? Well, yeah, I think so. I didn't draw this exactly to scale. I think this angle here is probably a little bigger than 11 degrees, so this side would probably stretch out even longer than it's drawn here. So this seems reasonable to me. So this is going to be 2,624 meters. This is actually useful if you're flying in a plane. If you want to know how long it's going to take for you to get to that atoll, if you want to drop a little care package onto it, if you can sight it and figure out the angle of depression, and you know how high in the air you are, you can figure out how far you have to go and how long it's going to take you to get there. All right, let's try one more. This one involves angle of elevation. It's got a different name, but it's very similar to the angle of depression. This one says there's a large totem pole near Colima, Washington. Well, totem poles are usually in the ground, so let's call that the ground, and this, of course, is going to be a 90-degree angle. We're already halfway to a right triangle, so that's good. And let's see, the totem pole is 190 feet tall, and on a particular day at noon, it casts a 177-foot shadow. That looks like 196. Let me fix that. So it casts a shadow, so like that, a shadow on the ground. That's 177 feet. What is the sun's angle of elevation? Well, to complete this triangle, let's think about the sun being up here, and it's shining, and it sends its rays down, and think about the ray of light that catches just the tip of the totem pole and comes right down to make the end of the shadow. Once you draw that line, you have a triangle, and this angle right in here, just like this angle was up here, this angle is going to be our angle of elevation. And that's actually what we're looking for, so we've got to call that angle x. Now we've got two sides and we've got an angle we want to solve for. We can do this with trig. We just have to use the inverse trig functions. So let's think about this angle here, this angle of elevation, and figure out what these sides are with respect to this angle. Well, this one down here is the adjacent, and well, the hypotenuse is this side that we're not concerned with. So this is the opposite. So we're going to do tan again, and remember, tangent is the opposite over the adjacent. So we'll set this one up like this. Tangent of x equals the opposite side, that's our 190, over the adjacent side, that's 177. And when we do this on the calculator, we can start with the division, 190 divided by 177. So we've got now the tangent of x equals 1.073. To solve for x, I have to undo the tangent part of it, so we'll do an inverse tangent of this number. So the way to do an inverse tangent on this calculator is to click the up arrow here, and then we've got the tangent with the little -1 up there, and we've got 47.5 47.03, let's say. So this angle is 47.03. And again, I just want to look at this problem and see if that makes sense. Could this angle be around 47.03? Yeah, it looks like it could be. So this seems like a reasonable solution to this problem. Well, that's a little bit of work with trig word problems.